Hello, everyone. Welcome to Python all day. Python all day. We are continuing with our journey on PyTorch. And before we continue, I wanted to take a minute and talk about NumPy. The reason I wanted to talk about NumPy is because when we are working with PyTorch, we will be working with NumPy every now and then, particularly when we are getting our data and also converting our data. Sometimes we will be able to get data in NumPy arrays, and we may need to convert this data to PyTorch tensors, so as we can be able to work with the data in PyTorch. So I just wanted to give you a very basic introduction to NumPy, and just so at least we can be able to have a little bit of some understanding on what NumPy is, and also some different ways to create and manipulate, or rather work with NumPy. Without much ado, what I wanted to mention is that NumPy essentially stands for numerical Python, and it is an open source library for the Python programming language, which has support for large multi-dimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. So NumPy stands for numerical Python, and NumPy is an open source library for Python programming language. And what it does is that it has support for large multi-dimensional arrays and matrices, along with providing a large collection of high-level mathematical functions to operate on these arrays. So it's more multi-dimensional arrays, matrices, and manipulation of the same. That's NumPy. And another thing I wanted to touch about NumPy before we start coding is that the speed. NumPy is implemented in the C language, and as such, NumPy operations are much faster when compared to traditional Python lists. So it's fast when compared to Python lists, and that's one benefit of the NumPy when compared to Python lists, is that it's faster because it's implemented in the C language. Another thing is the functionality. NumPy provides advanced mathematical and statistical operations at a high speed, including linear algebra, etc. And the other thing is the ecosystem of NumPy. It's actually a core library for other libraries like SciPy, Pandas, Matplotlib, scikit-learn, etc. So very good. I really wanted to take a little bit of a moment to kind of just introduce you to NumPy and just talk a little bit about NumPy, so at least you can have a little basic familiarity. If you haven't taken a NumPy class, you can just be a little bit familiar, because we will be seeing that we'll be getting some data in NumPy arrays when we are working with PyTorch, and we may need to manipulate that data so we can turn into tensors and utilize it when we are doing our when we are working with PyTorch tensors. So without much ado, I will go to Google Colab, and we will start coding and see how we can be able to create NumPy arrays. I want to be very fast because I just want this to be it's not going to be very intense NumPy course. It's more or less just going to be scraping and trying to understand the basics, just an overview. And I will go to my Google Colab. I'll escape this and I will go to Google here, and I'll just I'll Google Colab. And if you don't know, Google Colab is it's a very good IDE that we can use to write code. It's available online, and they have a free version which you can actually just sign in with your Google account and use. It's limited on the store on how much you can use, but for the most part you'll find it that it's going to be helpful to do most of the stuff that you may need to do, as long as you are not requiring intensive GPU use. Essentially, the reason a lot of people use Google Colab is because you have access to GPU, and GPU, as we'll see a little bit later, is very important when working with machine learning and also working with neural networks. We'll see that a little bit later, but that's really a big primary benefit to use Google Colab. But for now, we'll just go to Google Colab here. I already have an account with Google Colab, and when I go here, the first thing you see, they'll tell you to open a notebook. And Google Colab is more like a Jupyter, but in online. So Jupyter Notebook, more or less. But I'll click on New Notebook. And when I click on New Notebook, it brings me here. I just have to give a name to my notebook. And I am going to call this NumPy. I'm going to call it NumPy. I'm going to call it NumPy Notebook. And it gives you the extension .ipynb. And I press on enter, and I have my new Colab notebook, and now we can start writing code. In my window here for the cell where I write code, I have enlarged it, so at least when I do my print screen, you can be able to see what I'm typing, and you can follow along. So how do we create a NumPy? How do we create a NumPy array? Well, before we create a NumPy array, number one thing, we need to import NumPy, and we can import it as NP. So we can say import NP and import NumPy as NP. And for some reason, my Google Colab is doing the auto generation of the code. I think that's the thing with the AI thing. And I can just ignore some of them, and continue. So we import our NP, NumPy as NP, like that. And since we're working with machine learning and PyTorch and all that, my assumption is that at least you have a little bit of a basic understanding of the import, how to import packages on, in Python, and also how to install packages in Python as well. We don't need to install the NumPy because it comes with Python. But in any case, how do we create an array, a NumPy array? There are many different ways to create NumPy arrays, and I probably won't be able to go through all over them, but I'll be able to show you a little bit of different ways here and there, and which I've seen used commonly and also which are very easy to use. Number one way to create an array, a NumPy array, is using a Python list. So we can say here, we can say maybe we can have an array called A. So array A is assigned to np dot array. So this dot array, let me just open and close parentheses. So this np dot array is a method. It's a NumPy array. It's a NumPy method which helps you create a NumPy array. So it's a method. That's why we have the opening and closing parentheses. Opening and closing parentheses. That's very good to know because sometimes the parentheses can look so many of them, but you have to know which parentheses is for what. This is a method called array method, which is in NumPy. So, and this is the method that we use to create an array. So if you want to create an array from a list, we can say A is assigned to np.array, and then we are creating from a list. So we create our list inside this parentheses, and we have the list square brackets like that. So that's a list, and then maybe in this array we can create an array of a list, and the list as 1, 2, 3, 4. Yes, 1, 2, 3, 4. So there it is. We have A is an array, is a NumPy array made from a list, and the list is this one here. So if we come here and we say print A, then we have our array that we made from a list. My collab is kind of like initializing and running. Okay, there we are. So we have our array A here, which we made from a list, and it's 1, 2, 3, 4, 5. So that's pretty simple, pretty understandable. And we can also create an array from a tuple. Before we create an array from a tuple, just so we don't have things confused, I am going to take this list here, and I'm just going to define numbers. I'm going to say numbers is assigned to, and then I'm going to have that list there. So at least we can see that we are really creating an array from a list. I have those numbers there, and I can come here and say A is assigned to np.array, and then I can have my numbers there like that. And it's still the same thing as we did before. I click on run, and the same thing that we get. And this is how you run cells in Google Colab. You press on this, looks like a play button. So you just press on it, and that's how you run the cell. You run each cell individually, and you click on that. Alternatively, you can come here and click on run. You can either run all the cells if you have other cells. So there's a lot of different options, but I'm not really wanting to concentrate a lot on talking about how to use the Google Colab notebook. I just wanted to actually talk about creating NumPy arrays and working with them. So we created this from a list. You can also create an array from a tuple, and that's why I wanted to actually separate these two, bring these numbers to be like a list where you can see it here. And we can create an array from a tuple, so we can change this list to a tuple. We can just say opening parentheses and closing parentheses, and this is now, our numbers is now a tuple. And if I click on run, we have also created a NumPy array from a tuple. So you can also create a NumPy array from a tuple. This is the same thing as we cut this, we delete this, and we can put this here. This is the same thing, you see? And I press on run, and it's the same thing. The reason I wanted to start it with the numbers there is because you have the two parentheses, and I didn't want that to get in the way. So the outer parentheses here, the outer parentheses are for the NumPy array method, and the inner parentheses here are for the tuple. So that's how I wanted to show you. I also want to show you how you can be able to create a multi-dimensional array, and also how you can work with a multi-dimensional array. So suppose we come here and we change our A, and this time we say A is assigned to np dot array. See, that's the method, and obviously with our method we have to have our opening and closing parentheses, because this is a method. It's a NumPy method, NumPy array method. So, and this is the method that we use to create arrays. See, we have seen this. We have used a list to create an array with this method. We have also used a tuple to create an array with this NumPy array method. We can also create multidimensional arrays, like for instance, we can create one two-dimensional array like that, and we can say maybe 1, 2, 3, and 4, and then we can also create another one here of 5, 6, 7, 8, and we can end there maybe. So there we go. So we have A, which is assigned to a multi-dimensional array, and we can come here and print A, and I'll just print A. So we print A like that. So this A is a multi-dimensional array. I don't know if you look at it, this is a two-dimensional array essentially. We have one dimension here. See, this is one dimension, and this is another dimension there. So we have a two-dimensional array. Easy way to see it is that you can count 1, 2, these square brackets. We have 1, 2, and also at the end we have 1, 2. It's a two-dimensional array. It's a beautiful two-dimensional array. If you you click on it, then you have created a multi-dimensional array using NumPy's array method. So that's beautiful. And two-dimensional array, you can also, because we've talked about tensors before, and we've talked about tensors shape and size and things like that. You can tell from our previous video on tensors, it's the same way. This is, you can look at this and you can say this is 1 row, 2 rows. So this is a 2 rows, number of rows, 2 by 1, 2, 3, 4. 2 by 4. This is a 2 by 4 multi-dimensional array, 2 by 4. You see, you have 1 row, 2 rows, so that's 2, and then the columns, 1, 2, 3, 4, 1, 2, 3, 4 columns. So 2 by 4. So we start with the rows, columns, rows, columns, rows, columns, rows, columns, and you come here and you click on, for instance, we say print, and we print a.shape. We print a.shape, and what do we have here? We click on run, and we have 2 by 4, the way we said, 2 rows, 1 row, 2 rows, and then we have 1, 2, 3, 4, 1, 2, 3, 4 columns, 2 by 4. Very easy. And then we can also see, we said it's two-dimensional. You can also come here and print dimensions. To print dimensions, we say a dot n number of dimensions, ndim. And we click on that, we run, and we have our dimensions. If I click on run here, we have, it's two-dimensional array. If, for instance, I put another square brackets here, and another square brackets here, now this makes this a three-dimensional NumPy array. You can see we have 1 dimension, 2, 3, 1, 2, 3. 3-dimensional NumPy array. And the shape of this is, we have this, if you look at this very well, we have this purple square brackets. These ones cover everything up to there. And this is 1 dimension. It covers from the outside of the purple square brackets to the closing square brackets. This is one dimension, and then we have our 2 rows, 1, 2 rows in this other dimension, and then we have our columns. We have 1, 2, 3, 4. So the shape of this is going to be 1, comma, see, 1 for the outer dimension, comma, then 2 for the 2 rows, 1, 2 rows, and then 1, 2, 3, 4, then 4 for the column. So it's 1, 2, 4, 1, 2, 4. And if I come here and we can print the shape, we can also print the dimensions. If I click on run, then we have 1, 2, 4, and this, as we said, it's a 1, 2, 3, 1, 2, 3 dimensional array, NumPy array. We can also go a little bit deeper. We can put in another opening square brackets here and another closing square brackets here. And this now is a 1, 2, 3, 4 dimensional. 1, 2, 3, 4 dimensional array. And if you want the shape of this 4 dimensional array, we have this is 1, and then we have, you see the opening purple square brackets and closing purple square brackets, so that's 1. Then we have our second one here, our second one there, and that's also the opening blue square brackets and the closing blue square brackets. That's another 1. So we have 1, 1, and then we have our rows 2, and then our columns 4. So it's a 1, 1, 2, 4, 4-dimensional array. If we click on run and we run this, we have 1, 1. See, we have 1, 1. Then our number of rows 2. Then 4 for our number of columns. 1, 2, 3, 4 for a number of columns. And the dimensions, number of dimensions is 4. And we have seen that. So that's how you can be able to create a multi-dimensional array in a NumPy. And then another thing that I wanted to talk to you about will be about creating. I wanted to talk about specifying the data type of an array. How can you specify the data type of an array? For instance, once we've created our NumPy array, like 1, 2, 3, 4, this data type is an int. So if I come here and I click on print, and I print a dot d type for the data type, d type for data type, and I print that. So if I print this is going to be an integer. I believe it's int 64, but if I click on run, we have, this is 1, 2, 3, our array, and we have int 64 data type. Suppose I wanted this to be of a float, like say float 32. So to do that, you come here and to specify the data type, once you have your lists to create the array, then you can say d type, and you say this is assigned to, and this is an assignment operator. When I was doing programming long time ago in 2003 with Java, we had a teacher who was called instructor, who was called Mr. Dean. And he used to insist that this is an assignment operator, because a lot of times people say d type equals. This is not equals operator. This is an assignment operator. So you say d type is assigned to np dot float, np for numpy dot float, and we can say maybe float 32. And now that's how you can be able to specify the data type of your the contents of your NP NumPy array. And you click on run, you have this. Now it's a float 32, and you can even see that in the array we have 1 point, 2 point, 3 point, meaning that it's a float. It's a floating point number. Float 32, because we said float 32, we can say float 64 here, and it's going to be our float 64. And we click on run, and we have float 64. We can say float 16. Can we say float 16? Can we say float 16? And there we go. We have our float 16. And that's a beautiful thing to have. So that's how you can be able to specify a data type of your array. There is also another way that you can be able to create zeros. You can be able to create an array of zeros. If you want to create an array of zeros, there's an easier way to create an array. You can just write A is assigned to np dot zeros, and then after that you specify the size. So this is a 3 by 3 of zeros. If I click on run, we have an array of zeros, 3 by 3, 3 rows, 3 columns, 3 rows, 3 columns, 3 by 3. That's how you can create an array of a NumPy array of zeros. You can also create a NumPy array of ones. Wherever you can create zeros, you can also create ones, and you just say ones there, and lo and behold, you have a NumPy array of ones, just like that. It's easy way, quick way. If you want to create a quick array of zeros, a quick array of ones, where that you go. There it is. Then you can also create a NumPy array using a range. A range, I don't know that you know about a range in Python. And a range is normally used to create an array with a range of elements. With a range of elements, you specify the range. Just similar to how we use range with Python itself. A range with Python. So if I want to create an array of 0 to 10, but 10 is as I want to create from 0 to 10, or I want to create a range, an array with a range of 10. Remember, 10 is not inclusive, so I can say A equals to np dot a range, and I can say maybe 10. And I print A. If I come here and print A, what do I have? I print A. I should have to 9. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 is not inclusive. So if I want to do a range to 15, it's also going to be from 0 to 15, and 15 obviously is not inclusive, and there we have it. We go from 0 all the way to 14, with 15 not being inclusive. But that's how you can be able to create an array, a NumPy array with a range. In NumPy, it's just the same, a range, the same as it is used in Python. So I also want to show you something else that's pretty fancy. Linear space. You can create an array in linear space, but you create an array of values which you want to be evenly spaced and things like that. Let me just show you here. There is a method called NumPy method called len space, and we say np. You can say A is assigned to np dot len space, and I can probably say here len space, and I can specify from I can specify 0, I can say 5 here. I probably, yeah, 0, but I want this to be 5. I want this to be 5 or to be 1. Actually, I can use 1 there, and then I can use 5 here. So I can use 5 here. So what I'm saying is that I'm saying I want to create an array of 5 values, which are evenly spaced between 0 and 1. I'm saying I want to create an array of 5 values which are evenly spaced between 0 and 1. And if I click on run here, then we have 0. And as you can see, the D type here is a float in D type. But because I want from 0 to 1 and 5 values which are evenly spaced. So this is 0, and then from 0 we go to 0.25. Then from 0.25 we go to 0.5. Then from 0.5 we go to 0.75. Then from 0.75 we go to 1. Evenly spaced. From 0.75 to 1 is 0.25. From 0.75 to 0.5, difference is 0.25. From 0.5 to 0.25, difference is 0.25. From 0.25 to 0, difference is 0.25. Evenly spaced, 0.25. Evenly spaced. But this is how you use it if you want to be able to create an array with evenly spaced values, the values which are evenly spaced, as we saw with our 0.25. So one thing to mention about this is that np.linspace is a function in NumPy that generates an array of evenly spaced numbers over a specified interval. And it is normally particularly useful when you need a specific number of points within a range. And the name linspace normally stands for linearly spaced. Linearly, like linearly spaced. So linspace. Anyway, we can go to the next one before we get carried away by the beauty of Python. Another way that you can be able to create a NumPy array is by using np.I, and this will normally create a matrix for you actually. So NumPy, we can just see it in action. We can say A is assigned to np.I, and we can say maybe I4, for instance. We provide the number of dimensions, and this is going to create for us a matrix, a 4x4 matrix. And if I click on run, for instance, I have to print it. Before I click on run, I print my A. So I print my A and I click on run, and as you can see, we have NPI. It creates 4x4, but this is what we call an identity matrix. If you look at this, our 4x4 matrix we have created here, you can see if you look from 1 here and you draw a diagonal line here, you can see the 1 runs right across the diagonal line. And this is where I wanted to just touch a little bit of base, just to let you know about and this is what we call an identity matrix. And an identity matrix in NumPy is a square matrix with ones on the main diagonal. That means the main diagonal, This is the main diagonal here. The main diagonal is from the left, or the top left, to the bottom right. And what this is that it has ones on the main diagonals, and then it has 0 everywhere else. So it has ones on the main diagonal from the top left to the bottom right. Main diagonal, it has ones, and then 0 anywhere else, everywhere else. And this is what we normally call an identity matrix in NumPy. And to create an identity matrix in NumPy, you use np.I, and then you specify the number of dimensions. And this is 4 by 4. We can maybe say 6 by 6, and we click on run, and we have an identity matrix 6 by 6. We can say maybe 20 by 20, and this is going to be very big, and we have 20 by 20. But again, this is good. You can see it's an identity matrix because the main diagonal has ones. I start from the top left, and I have the main diagonal. I just go through with it all the way to the bottom right. I have 1. Otherwise, everything else, it's a 0. This is an identity matrix in NumPy. You have 1 in the main diagonal, and everything else is a 0. And that's how you can be able to create an identity matrix in NumPy. And then another thing I wanted to talk about, obviously, another way to create a NumPy array is by using the random, and also the random int as well. So for instance, say you want to create an array with random floats. Create an array with random floats and between 0 and 1, for instance. So we can just come here, and suppose we say this, our A now is, we want it to be a floats between 0 and 1. Then we can just come here and say it's np dot random dot rand. And I need to type this better, dot rand. And I can maybe say, specify the rows and columns. I can say maybe 3 rows and 2 columns, like that. 3 rows and 2 columns, sorry. 3 rows and 2 columns is what I want. I want 3 rows and 2 columns. I specify like that. So we have np.random.rand, and this is how we create floating point random numbers between 0 and 1, and this is going to be an array of size 3 times 2, meaning 3 rows and 2 columns. So if I click on run here, we have, I need to print it. We print A. So we print A, and if I click on run here, we have our array of random floating numbers between 0 and 1, and there it is. If I click on run again, I have another one and another one, but that's how you can do it. So that's how you can print an array of random. The rand normally generates floating point numbers between 0 and 1, and you just specify the number of rows, 3 rows, 1, 2, 3, and also the number of columns, 1, 2 columns, like that. If you want to generate a random integer, then for instance, instead of generating a random floating point number, I can generate a random integer. For instance, we have to change this. Let me just start from the beginning. We can say np.random dot rand for random, int for integer, and then I can specify the range where I want to have this random integer. So I can say 10 to be the range, and the size, we can say the 3 and 4 that they provided, and maybe we can just see what that prints. So we are printing a random integer, and we need a closing parenthesis here. And if we click on run here, we have 3 by 4, 3 rows, 1, 2, 3 by 4, and it's between random integer. The range is between integer from 0 to 10, but 10 is exclusive, so we have our 10 not appearing anywhere here. If we run again, we won't include 10. We have 0 here, but we never include 10 because 10 is exclusive. 10 is exclusive, so it's not included. It's just the same way as we're working with a range. 10 is exclusive, so it won't be included. With the generation of these random integers, we can get anything, but not 10, not 10. And we can also specify here, we can say, maybe if we don't want to start at 0, we can say start at 2 to 10, and then we also give the size. And now 2 is inclusive, but 10 is exclusive, as we have seen with a range. 2 is inclusive, so once we generate these random integers, we'll have 2 somewhere. And we don't have 2 now, but if I run again, we may have 2. We have 2 now. Woohoo! We have actually 2 2s, 3 2s. We have 1, 2, 3 2s, but 2 is included, and that's how you can be able to create a random int by specifying. You can specify where you want to start and also where you want to end, and you also specify the size of the NumPy array that you want to be generated. We go next. I want to go next and see how we can be able to use np.full. And this will normally create an array filled with a specified value. Like for instance, if I come here and I say my array, NumPy array A is assigned to np.full. This is a method in NumPy, and we open the parentheses to open that method, and then inside this method we specify the number of rows and also the number of columns, and we also specify the thing that we want this array to be filled with. It's more like the way we are generating arrays of zeros and arrays of ones, but this time instead of zeros, ones, we actually specify the number that we want to be in there. So we can say like 7. So if I come here and I have to specify the size, I can say 4, 7, or maybe 4, 8. And I also specify what I want in it. I can say 7. And if I come here and I say print A, if I come here and I print A, and I click on run, I'm going to have an array of 7s. Oh, this looks like the lucky number. Ooh, I'm going to have an array of 7s, and we specified the shape. If you look at the shape, the size, it's 4 by 8. So we have 4 rows, 1, 2, 3, 4, and by 8 columns, 1, 2, 3, 4, 5, 6, 7, 8 columns. That's an array, and this is obviously, you can see, it's a beautiful array. You want the dimensions of this array. This array is a 2-dimensional array. We can see 1, 2. So we can come here, print dimensions, print. Remember the way we said we print dimensions? We say a.endim, number of dimensions. And this should be a 2-dimensional array, as you can see, 2-dimensional array. So that's beautiful. We can go to the next one. I want to show you something a little bit And this is just essentially, we are just catching on the basics of NumPy. Just wanted to make you a little bit comfortable and kind of like try to see how we can work with arrays in NumPy. Just because we'll be able to work with these arrays, NumPy arrays, when we work with PyTorch sometimes, because we may need to convert these NumPy arrays into tensors, and that's why I thought it would be a good idea to talk a little bit about NumPy. There's something that I wanted to show you. I think it's fancy. I wanted to show you working with NumPy arrays. You can actually use NumPy normally provides a function called from function, and you can create an array from function. And I want to show you a very good example here. And essentially, the from function, what it does is that you create an array and you fill it with a function that operates on the array indexes. Like for instance, let me show you here. Let's say our array A is, before we actually come to our array A, maybe we create a function here. Maybe we create a function and we can just say def function. Maybe we can call it def function, yeah. And we can say this is a takes in I, it takes in I, and also takes in J. And what this does is, it fills for me, yeah, it returns, so it returns, return I plus J. It returns I plus J, like that. So it returns I plus J. But so let's say we have our array here now, our array here, and we can assign this to our NumPy array A. We can now assign this to, we can use the np dot from function, and we can call this function and make some operations on the indexes and then try to see, maybe work on it a little bit. But let's see how it works. It's a little bit, I think it's easy. It can also, initially it can be a little bit maybe like, oh, what's going on here? But once you actually see how it's working, it just makes a lot of sense. So, but we can use the np.function. You can say np dot from function, and actually they did specify that for us. So anyway, so we have np dot from function, then we now call this function, and we call this function and we get the call of the function. And let me just explain to you what this does before I click on run, at least so we can be able to have an idea. So the np.from function is a NumPy function that creates an array by executing a function over each coordinate. It is particularly useful when you want to create an array where each element is a function of its indexes. The function allows you to generate arrays based on custom functions rather than explicitly defining each element. And so like for instance, we can have that, and so this, maybe we can create an array. This is the size, we can have this, the function, which is going to return I plus j, but the I plus j is going to be the index of each coordinate. So we have the function, we call the function here, then we specify the type that we want of the generated array, and also we specify the data type. And now if I click on run here, we can see, let's try to see what we got here. And actually, to see better, I want to see if I can actually just copy this and type it, maybe see, I can type here what we get. So at least we can be able to see a little bit better. And I actually, I can use that. Yeah, I can use that, and we can see what the output was. So, and I want the output to be on 1 like that, and it's a little bit better to see now the from function. But what it does is that it just does what it says it's gonna do. So we have this 0. You know, the way we defined it can be a little bit complicated, but I think the definition of it is a little bit complicated. But once you see it in work, it's actually easy. So we have easy way to understand it is that we sum the rows and the columns. So like ij is going to be the sum of the row and also sum of the column. Like this one here, the first coordinate is the sum of the first row and also sum of the first column, which happens to be 0, because row column 0 and row 0, you add them together is 0. Then we go to row 0 but column 1 is 1, row 0 but column 2 is 2, row 0, this is row 0 but column 3 is 3, row 0 but column 4 is 4. This is row 1. Remember, we're talking about the rows. We have row 0, row 1, row 2, row 3, row 5. Then we have column 0, column 1, column 2, column 3, column 4. So this is row 0, column 0, we have a 0 there, because 0 plus 0 is 0. It's the sum, because we are saying we are returning I plus j, so we are returning the coordinate of the first column and the coordinates of the first, sorry, I have to be very clear on this. We are returning the coordinates of the first row. I really want to start with the rows and then go to the columns, because that's a very good way to get used, especially when you're working with tensors, and also we are working with NumPy arrays. We start with the rows, columns. So this is row, coordinate of 0, column 1, coordinate is also 0. So that's why we have 0 plus 0 is 0. Then this is row coordinate is row is still 0, the column is 1, and that's where we have 0 plus 1, we have 1. The row coordinate here is still row 0, so that's 0, but the column coordinate is 2, that's why we have 0 plus 2 is 2. Like that, 3, 4, and then here we come here, this is row 1, so the row coordinate here is 1, but the column coordinate is 0, that's why we have 1. The row coordinate here is 1, we're in row 1, and the column coordinate here is 1. The row coordinate here is 2. The row coordinate here is 1. We are in row 1. Row 0, row 1. So here the row is 1, but the column is 0, 1, 2. The column is 2. So 1 plus 2 is 3. The row coordinate here, we are still on row 1, so it's 1, but the column coordinate here is 0, 1, 2, 3. So 1 plus 3 is 4. Then the row coordinate here, we are still on row 0, 1. We are still on row 1, and the column coordinate here is 0, 1, 2, 3, 4. So 4. So we have 4 plus 1, column 1. 4 plus 1 is 5. We come here, we are now in row 0, 1, 2. We're in row 2. So the row coordinate here is 2. The column coordinate is 0. 0 plus 0, 2 plus 0 is 2. That's why we have 2 here. Then we come to the next one here. The row coordinate here is 0, 1, 2. We're in row 2. And we are in row 2, so that's 2. And what is the column? We have column 0, 1. Column 1. So 2 plus 1 is 3. And here, the row coordinate is row 2. The column coordinate is 0, 1, 2 is 2. We have 4. Here, the row coordinate 0, 1, 2. We have 2. The column coordinate is 0, 1, 2, 3. 3. 2 plus 3 is 5. And here, we are in row coordinate 0, 1, 2. Row coordinate is 2. And the column coordinate is 0, 1, 2, 3, 4. So 2 plus 4 is 6. And here, the row coordinate is 0, 1, 2, 3. 3. And we have row 3, which is 3. And column 0, which is 3 plus 0 is 0. Then we have row 3 and column 1. 3 plus 1 is 4. Then we have row 3 and column 2. Row 3, column 2, and we have 2 plus 3 is 5. Then row 3 and column 3, we have 2. We have 3 plus 3 is 6. Then row 3 and column 4. So 4 plus 3 plus 4 is 7. And then here we have 1, 2, 3, 4, 5. This is row 5. So this is row 0, 1, 2, 3, 4. Sorry, this is row 4. So we have row 0, 1, 2, 3, 4. So this is row 4. And we have row 4 plus column 0 is 4. Row 4 plus column 1 is 4 plus 1 is 5. Row 4 plus column 2 is 6. Row 4 plus column 3 is 7. And row 4 plus column 4 is 8. So this is a very good function if you wanted to get, it's of course the from function. It creates for you a NumPy array from the coordinates, from the sum of each item in the coordinates. It's very beautiful. It's also very fancy, but that's another way you can be able to create. You can be able to create a NumPy array. This time, applying some modification with a function, which I think is very beautiful. But I wanted to mention that so at least you can be able to also see that. And then there is another way here, another one I wanted to show you called tile. And a tile is essentially if you want to create an array with repeated patterns. Like for instance, if I come here and now I don't need this, so I can just click this, and I don't need this function that I had, so I'll just go ahead and take that function out. But suppose I come here and I say my array A is assigned to, and I say np dot array, actually not dot array, I say np dot I can say dot array, and I have an array of 1, 2, maybe I can have an array of maybe I'll have a two-dimensional array. I'll have a two-dimensional array, and in the first dimension I'll have 1, 2, and then in the other row I'll have 3, 4, like that. And I have that. And I have that to be my array, array A. And then I want to create, another array, but I want to be able to repeat this 1, 2, and also repeat this 3, 4 in the other array that I create. So I just want to expand my array, making different repetitions. So I can come here and I can say my array B, and I can say this is assigned to. Now I can say np dot tile, and then I pass in my first array. Let me see. So this is printing for me. I don't want it to be printed. Anyway, so I have my B array, which is np.tile, but I pass in my A array, and I also give the tiles that I want to run along the rows and also along the columns. For us to be able to see the rows and columns very well, let me just put this to be 5, maybe 2, 5, and maybe we can be able to see. Because if I have 2, 2, then we won't be able to see which are the rows and columns and all that. So this means that what we do is that we're going to take this array A, and then what we'll do is that we'll tile 2 times along the rows, and also tile 5 times along the columns. And that's why I wanted this to be a 5, so at least you can see the difference. And if I come here and I say print, and I print B, and I click on run, you can see I can maybe take this and bring it here, so at least you can be able to see it better. I'm gonna just bring it here and bring it as a comment, and I'm just gonna put it there like that. And I will move this a little bit, so at least we can be able to see better how they look like. I can bring that there, I can bring that there as well. Just wanted us to be able to see it better. Oops, I don't want to do that. So I want us to kind of like see it where we can see everything. There like that, and I bring this like that. And now we can maybe see it a little bit better, but you can see that, you know, you can see how many times we are repeating. For the rows and columns, we are tiling 2 times along the rows and 5 times along the columns. So these are our rows. You know, we have 1, 2, we have 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and we also have 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, like that. So we are tiling 2 times, this 1 time and 2 times along the rows, because we said we tile 2 times along the rows. So we took this 1, 2, we tiled it 2 times along the rows. Then we also took this 3, 4, and we tiled it 2 times along the rows. You can see that this is 1 time, 2 times. For the 3, 4, we tiled it along the rows 2 times. And we also tiled this 1, 2, 3 times along the rows. But we also tiled along the columns. Along the columns, we tiled 5 times, and if you count, this is 5 times. This is, suppose we just maybe have this like this, and we move this a little bit there so you can see better. So along the columns, you can see how the columns look like. It's 1, 3, and 2, 4. So, but along the columns, we tiled 5 times. So we have 1, 3, 5 times. We have 1, 3, 1, 1, 3, 2, 1, 3, 3, 1, 3, 4, 1, 3, 5. 1, 3, 5 times along the columns. 1, 3 appears 3 times along the columns, and then we have 2, 4. And 2, 4 appears 5 times, 5 times along the columns as well. So you have 2, 4, 2, 4, 2, 4, 2, 4, and 2, 4, 5 times. So this is another way, and essentially you may ask, why do we need the np.tile? It's a fancy pattern, but really, why do we need it? And typically the np.tile function is very helpful for constructing arrays with a repeated pattern, which is common in certain applications like texture generation or tiling backgrounds. And so it has its own application, and it's also useful when you want to create a larger array by tiling or repeating a particular pattern along one or more dimensions. And so there you have it. That's another way that we can create an array that you want the array to repeat a certain function. It has its own applications, so there is where we are. And that was creating an array with repeated patterns, And now I want to also show you how you can be able to use the np.repeat method. np.repeat method to create a NumPy array. And the np.repeat method just helps you repeat elements of an array. Suppose I have an array A here, and this array A is just an np.array, and it has 1, 2, 3, 4. It has 1, 2, 3, maybe even 4. That's fine. And maybe we don't need 5. Maybe we don't need 5. And then I want here, I also have another array called B, and I want this array B to be np.repeat. I want it to be np.repeat, and I want to repeat my array A, and I want to repeat it maybe, let's say, 3 times. So I want to print B. I can print B here. And if I print B, I click on run this, you're going to see we have this repeated array A. We have an array with every element in my array A repeated 3 times. So we have 1 repeated 3 times, 1, 2, 3. We have 2 repeated 3 times, 1, 2, 3. We have 3 repeated 3 times, 1, 2, 3. And we have 4 repeated 3 times, 1, 2, 3, 4. An array with the items in our original array repeated the number of times that we specify. That's another way that you can create an array in NumPy. There is also another method that is called from string, and I wanted to show you how you can be able to create a NumPy array from string. Let's say that I have an array here called A, and my array A, or actually let's say that I have a string here. I have a string, my string, and I'll call this string, I'll have it be a string with 1, 2, 3, 4, 5, and I want to create my string. This should be underscore like that, my string, and I want to create an array from this string. So I can just come here and say A is assigned to np.fromString, and I put my separator. My separator is the comma. How do I want my items to be separated? They are separated by a comma. And I can say A equals to np.fromString, and then I'm from my string, and then I have my separator as the comma. and I click on run, and I have my 1, 2, 3, 4, 5 printed from a string. But you can see it's actually printing. When we look at the D type, you can look at D type here. D type, we can print the D type. Print a dot D type. Print a dot D type, and if I click on run, we have float 64. So it's a float. So it looks like the from string method returns a default D type of float. How about if I want to specify the D type? Remember how we said we can specify D type. We can say D type, D type, D type, D type, and we can say D type is assigned to, and we can say np dot D type. Don't need that. np dot D type, and we can say D type, np dot D type, and then we say int, and we can maybe say int 32, maybe we can see int 32, and we have to close the parentheses here. And if we click on run now, this did not work out. What went wrong? Attribute error, D type, module NumPy has no D type. D type, it's my spelling, people. D type int 32, then I click on run, and something else going on here. What is going on in the world? Int 32 is not defined. np.d type. Int, sorry, maybe int, and there we go. So we have int D type. We can specify the D type to be int. We can, and most of the time this thing, as we work with it, we are also learning. And one thing, the beauty about programming is that every time you'll have some bugs here, and you'll also be able to get a lot of ways to learn, because you just can't really know everything. And there's always, these things keep on changing every time technology changes. So, but that's how, you'll be able to run some code and run into some errors. And that's why part of programming, a very big part of programming and coding, is also debugging. Be able to debug those errors as they occur. And as we go to model development, machine learning, and deep learning, we will run into a lot of errors. So I want you to get used to the idea that errors are part of learning, and they teach you a lot as you program. So that's one I wanted to talk about, how we can be able to create an array from a string using the from string NumPy array method. And this method is handy for converting data that you received as strings, and you want to directly convert that to NumPy arrays. So suppose you got a comma separated list with a lot of data, like thousands of pages of numbers which are comma separated, and you want to convert those numbers to an array. Then very easy method, you can use the from string method, and there you have it. And then one more thing I want to show you is the np.diagonal method, and it's just for diagonal matrix. I just think it's cool, and it's something that I can show you. So suppose we have we want to create a diagonal matrix, and we can just come here and say A is assigned to np.diagonal, diag for diagonal, and we can just come here and say we can create our matrix, and we can say 1, 2, 3, 4, And when I click on run, we're gonna have a diagonal matrix and with 1, 2, 3, 4. So I click on run. Oh, I need to print it. Why do I always forget to print it? Print A. We're gonna print A. And if I print A, we have a diagonal matrix of 1, 2, 3, 4. But look how beautiful it is. 1, 2, 3, 4. But it's a diagonal matrix, meaning that the 1, 2, 3, 4 is along the main diagonal like this. 1, 2, 3, 4. It's like diagonal line like that. I can, maybe I don't know whether you can see it better, but I can bring it here so you can see the beauty. You can see the beauty of the world. This is the beauty of the world, and I always have to push this a little bit. Maybe I put it on its own line. Maybe let me just do this, because every time I do that I have to. So suppose I bring it there, and you can see, well, we need to do this, but you can see diagonal, the 1, 2, 3, 4 is 1, 2, 3, 4, and they make a beautiful diagonal line. So that's how you can also create a NumPy array with a diagonal line. We can make this, we can maybe have 7, 8, 9, 10, blah, blah, blah. But anyway, you get the idea. Diagonal, it prints an array with the main diagonal being the numbers that you specify, and the rest of the numbers are going to be 0. So that's how you can do it. And one thing I want you to know is that, rather I want to mention, is that the NP diag, the one that draws with diagonal line, can be used both to create a diagonal matrix from a 1D array and to extract a diagonal or create a diagonal matrix from a 2-dimensional array. So it has its own use cases, but I wanted to introduce you to that just so you can be able to see the different things that we can be able to do with an array in NumPy. Another thing that I just wanted to mention before I start finishing everything, I'm actually trying to finish everything now, but another thing I wanted to show you just some basic indexing in arrays. You know, say we have a 1-dimensional array like our 1, 2, 3, 4, and we want to index, like for instance, let me say this, we can maybe change this to np dot array and we can make this a 1-dimensional array with 1, 2, 3, and 4 maybe, and say that we want to access number 3. We want to access the number 3 and print it out. So pretty much the same way as you've dealt with other arrays, it's pretty easy to be able to access an item in array by its index. Remember, in arrays we index from 0. So this is index 0, index 1, index 2, index 3. Maybe I should change this to something else so we don't get confused with the indexes, and something else, 7, 8, 9, 10. So this is index 0, index 1, index 2, index 3. In arrays, in NumPy arrays, just as with other arrays, we index starting at 0. So if we want to access, maybe say number 9 by its index, we can start with here, we can start with 0, we can start with 1, 2. So this is index 2, it's 9, and if I click on print, and to index it, we just use the square brackets like that, and if I click on run, this is going to print for me 9. So we have accessed 9. If I want to get like 9, you know, I can also get 9, believe it or not, I can get 9 by saying negative index 2 as well. Index 1, negative index 1, because this is negative index 1, negative index 2. I think we should be able to get 9. I believe that should be, yeah, negative index. So here, when we are doing negative, we start with negative index 1. So this is negative index 1, this is negative index 2, this is negative index 3. So if we say negative index 3, it's going to be, it's going to be 8. So 8 there, like that. So coming from this way, we start at negative index 1, negative index 2, negative index 3, negative index 4. But going this way, we start with index 0, 0, 1, 2, 3. So that's pretty good. 0, 1, 2, 3. When we're coming this way, we can also access it from right to left, but we start with negative index 1, negative, because there's no negative index 0, obviously. Negative index 2, negative index 3, negative index 4. So that's how you can be able to access. This is a one-dimensional array, obviously. It's one dimension. If I come here and I print a dot ending, it's going to be 1. It's not printing for me. Ending is going to be, I just wanted to write this so we can actually refresh as we go. I like to refresh as we go because that makes it easier for knowledge to be able to retain knowledge. So we talked about ending, but this is one dimension array, and you can see that this is one dimension array. And we can also do the same thing. We can see how we can be able to index multi-dimensional arrays. Suppose we have two-dimensional array. Instead of this one being one dimension, we maybe have 2 dimension, and in the one we can have maybe 1, 2, 3, and then we can have another array here, 3, 4, 5, and maybe another one, 6, 7, 8. So we have that, and this is a 2-dimensional array. The shape of this is, we have 1 row, 2 rows, 3 rows. So we need to open this. How did I forget that? And we need to close this too. How did I forget that? So this is a 2-dimensional arrays. We have 1 row, 2 rows, 3 rows. So that's a 3 by 3, and 3 columns. 1, 2, 3, 1, 2, 3, 1, 2, 3, 3 columns. So 2-dimensional array with 2 rows and with 3 rows and 3 columns. So it's 3 times 3, and dimension is 2. But we can just create a dot shape, so you can see that, and we can print a dot shape, and if we click on run, we have 3, 3. But that's not the point. Essentially, the point is to see how we can be able to access these elements. And accessing elements in an array, just like any other array, is as easy as get the element, get the row, get the column. So if you want to access, for instance, row 2, column 3, we can say here A, and for row 2, column 3, the row 2, this is row, this is row 2, column 3. This is row 1. This is row 0. We start with, when we're indexing, we start with row 0. So this is row 0, row 1, row 2. And we want to access row 2, column 3. And column 3, that's the 8 number here. So that's the 8 number. Row 2, column 3 is the 8 number. So we can say row 2 and then 3. And then if I click on run, I need to have the closing parentheses here. If I click on run, I get an error. What is the error coming from? I hate the errors. As much as they're part of learning, I don't like them. Where is the error? We want to access print A. a 2 3. Where is my error? I don't know what's it saying. Index 3 is out of bounds for axis 1 and 3. So we wanted to access this 8 here, and this 8 here is oh, sorry, yeah. So this 8 here is, we have row 0, and then we have row 1 and row 2. So the row 2 is fine, but the column, when we are accessing the column, we start again from column 0, column 1, column 2. So our 8 will be column 2. Sorry about that. Our 8 will be column 2, and we have our 8 like that. So we should have started 0, 1, 2. So if we want to access like this 3 here, this 3, we start, it's two-dimensional array, so we start with the row, and the row for 3 here, this 3 here, it's row 0, it's row 1, so it's going to be row 1, and the column is going to be column 0. So row 1, 0, we run, we have a 3. If we want to get this 6 here, again, our 6 is going to be, we have row 0, row 1, and row 2. So we are going to be in row 2. And what column? We are in column 0. And we have our 6. So that's how we can be able to access, we can index in multidimensional arrays in NumPy. And the dimensions can be, this is a two-dimensional array. It can be 3 dimensions, it can be 4 dimensions, same concept, but that's something that I really wanted to show you, so you can be able to know how you can be access that in case you did not know how to access multidimensional arrays. And then I also want to show you something else about how we can be able to slice. One-dimensional arrays as well as multi-dimensional arrays. Suppose I have an array, and I'm going to use the A range to create an array of 0 to 9, which is going to be A equals to A range. It's assigned to, remember, np.arange. And what we're going to do is that this A range is going to take in 10. And if I come here and I print my A range, print my A, I have obviously 0 to 9. And there we have it, 0 to 9. But suppose I want to slice. And I want to index, to slice or to get a subset of my range. We have range from 0 to 9, but I want to get a slice from, like, say, maybe 2 to 5. 2 to 5. I want to slice from 2 to 5. Remember, when you are slicing, the first one, I can come here and maybe I can say B. I can say my B is assigned to, I can say A dot, and I can use my slice. And the way we do slice is actually, we can actually do it. We can just put the parentheses here, and then we can say 2. I want from 2 and from 2 to 5. So the 2 is inclusive, the 5 is not inclusive. So we're going to have 2, 3, 4, and there. So if I click B, if I click on print B here, print B, B is going to be 2, 3, 4, but not 5, because 5 is not inclusive. And again, what did we do here? Print A. Instead of printing A here, I should actually have assigned I should have assigned the actual here. I can say, I don't know why it's bringing too many indexes in array, one dimensional, but two were indexed. 2, 5. I want to index 2, 5, slicing from index 2, 5. Sorry, my bad. 2, 5, it's a slice. Sorry. Slice, we use the full colon to slice. Sorry, that one I don't know why I did the comma there, but we've been working with commas a lot. But we are slicing, so we are saying from 2 to 5. So you have the comma there. Sorry, and I click on run, and there we have it. We have 2, 3, 4, and we want to. So that's 2, 3, 4. And suppose we want to go from 2 to 8, you get the idea. We're going to go from 2 to 8, but 8 is not inclusive, so we print 2 to 7. If I click on run, we have 2, 3, 4, 5, 6, 7, like that. So you get the point. We can also slice from, just like we work in lists, and I want to just show you, just like lists in Python, we can also slice from, this is saying from the beginning, that's from 0 to 8. Instead of going all the way to 9 with a range 10, we can say all the way from 0 to 8. And if I click on run, this prints from 1 to 7. 8 is not inclusive because obviously we have said that. 8 is not inclusive. Other way, we can also leave this blank and we can come here and say start at 3 all the way to the last item in the A range, which is going to be 9 because 10 is not inclusive. And we are going to start at 3 all the way to 9. And we click on run and we have 3, 4, 5, 6, 7, 8, 9, like that. So that's how you can be able to slice using one-dimensional array. And we can also see how we can work this. And this is one-dimensional array, obviously. And how about doing it with multi-dimensional array? Multi-dimensional array. So for instance, we can come here, we can create our A. We're going to work with A because we've been working with A and we love A. Let's say A is assigned to np dot array. And then we have, maybe let's have two-dimensional arrays. 1, 2, and for the first dimension we can have 1, 2, 3, and for the next dimension here we can have 4, 5, 6, and also we can also have 7, 8, 9, maybe 7, 8, 9, like that. So we can have that array there. And then say that we want to be able to get a row slice. Maybe we want to slice the first item in a row slice. We want to get a row slice. We want to get a slice of maybe the 0 row, the first row, or the second row. So we can just come here and we can say, maybe we can say print. We'll use print a lot. We can say print, and for the row slice, if I say print A, this prints the whole array, obviously. It prints the whole array. But if I want to print the first row, I can say print A, and this is gonna be 0. So we're slicing the first row. Remember, the first row is index 0. So if I click on run, we have our first row 1, 2, 3 being sliced. I can also slice the last row like that, -1. Remember, we said last row -1, 799. If I click on run, we have 799. We sliced our last row. And if I want to slice this row here so it doesn't feel left out, this row can be -2. Or, so we click on it, it's going to be 4, 5, 6. Or it can be 0, 1. It can be the 1. So if we click on 1, and it's the same thing. So very easy concepts really to understand. And but we also want to see how we can be able to access we can be able to access a number from a two-dimensional array. So it's just the same way as we saw. We have to go with the rows, then the columns. So suppose we want to access the second row. This gives us the second row, 4, 5, 6, but we want to get 5. So 5 is going to be 0, 1, 0, 1. So this is going to be 1, and I believe we can access it like this. No, that's inside array. I believe we can access it like 1, and 1, if we say 1 and 1, 1, that will give us empty array because that's the first empty array. How about we say 1, and then we also access the first one is 1, which is here. Then we access 0 for 4, and 5 we access 1, like that. That's, I think, what I was looking for. Yeah, so just the same way as we do with arrays, you can just access multidimensional arrays by going one step deeper. So this one, this A1, the first one refers to the first dimension, and our first dimension here is where we have our rows, and then we have 0 row, and then we have row number 1. So A1 is row number 1, and then we go to the columns, and the columns, because it's a two-dimensional array, the columns will start at 0, then 1. If we want to access this number 9, then we go with the rows, row 0, 1, 2. So this is 2. We're in row 2. This is row 0, row 1, row 2. So we're in row 2, and we want to access the last 9, maybe the last 9. Both of them are 9, so we won't know which one came back, but believe me, it's going to be the last 9. But we come here to, maybe we can change this to 8. So we don't have that. So if we want to access the 9 now, we have 0, 1, 2. So we can say 2, 2. And when we click on run, then we have 9. So that's how you can be able to access. It's just like nexting, and it's just more or less the same way we normally work with arrays in other languages, and also, but that's how you can be able to access multi-dimensional arrays as well. There's also another method. There are a lot of methods that we can work with on NumPy with. I just wanted to maybe try to see if I can finish this up. I cannot really go over them, but I wanted to just introduce you a little bit to NumPy and show that there's a lot of things that you can be able to do with NumPy, just because we'll be able to work with NumPy a lot as we start with PyTorch, because we'll be getting some data in NumPy arrays, and we may need to convert that into tensors, so we can work with our PyTorch. One more thing, just before I finish up here, I want to show you something about Boolean indexing, like Boolean true false, Boolean indexing. Just want to show you real quick before I finish up. I really feel very happy to. I just love to program. But let's say that I want to just introduce you to how you can use Boolean arrays for indexing. Suppose you have an array here called array A, and this array is an is a np dot array, and it's a one-dimensional array with numbers from 1 through 1, 2, 3, 4, 5, 6, 7, and we just stop there. 7. We just stop 7. I want 7. I want 7 there. We 7, then we stop at 7. There we go. We stop at 7. Suppose I wanted to print print what do we say? Let's say I wanted to print let's say I have another array here, and I call it array B, and I say B is assigned to, and I say B is assigned to A greater than 3, maybe. Greater than 3, yeah, why not? And then I say I want to print B. I can come here and say print B, and it should be able to print anything that's greater than 3. So if I click on run and I'm printing B, it's going to print if anything is greater than B. I'm printing the result of this operation here. This is an operation, and you know, it's printing if A is greater than 3, so it comes to the first one, it prints false. The second one, it prints false. The third one, it prints false. The fourth one, 4 is greater than 3, prints true, 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 like that. So that's another way you can be able to run. You can be able to kind of like see whether, you know, whether an array, like you can try to run the Boolean evaluation for true or false over a NumPy array. And it's something that I just wanted to let you know. So we are not limited with evaluations with numbers and strings. We can also use Boolean and to access values, or also to access values, and also to make evaluations on whether a statement is true or false, or evaluates to true or false. And that's one way. Also, you can use Boolean values to be able to work with arrays. And I think for now we got a little bit of some introduction to NumPy, and that's what I was wanting. One more thing before I go, as we have seen with tensors in my previous video, you can also add, subtract, multiply NumPy arrays. I just want to show you that before I go real quick. Suppose we have an array here. Let's say we have an array. We can just say a one-dimensional array, np dot array, and we can do like we can maybe have a one-dimensional array of 1, 2, 3, 4, 5, and we can also have b. We can have b, and we can have this b being another np dot array, another one-dimensional array, and we can have it as 6, 7, 8, 9, 10, like that. So suppose we want to add this array. Number one thing you have to know, it's element-wise addition. Most important thing in element-wise addition, element-wise subtraction, element-wise division, element-wise multiplication. the shape has to match. The shape, the size has to be the same. Like this is, the shape of this, it has one row, and this is a one-dimensional array. One-dimensional array. This is a one-dimensional array. This is a one, and this is also a one. If we come here and we say print, and we'll print shape, we'll print a dot shape, and we also print b dot shape, and we click on run. The shape has to match. We click on run, and I hope Colab is working, because sometimes it doesn't work. So it still shows that it's running. I'm gonna just stop it. And call is already running. It's taking too long to run, and I am gonna maybe see if I can stop it. Sometimes we can run into this with Colab, and I think I'll just come here and I will come on runtime and I'll say run selection. Maybe I just want to stop this first. This is one thing about the price of Colab. Sometimes it kind of like acts up a little bit. And let me see, run all. Yeah, it's a little bit slow. I'm gonna wait for it to finish running, and then I can be able to see. Oh, I wish it wasn't slow. Otherwise, I wanna print the shape, because we're gonna do multiplication, addition, subtraction, and division. I'm gonna wait for it to run. Oh, it hasn't run yet. So what I'm gonna do is that I'm gonna just restart this again. I'm sorry guys. I'm gonna restart this again, because this is Colab for us. Sometimes, I'm gonna just reload the whole thing, just because I want to be able to run this. And there's an error somewhere. Where is the error coming from? We have NP array, and what is the error first? Module NumPy has no attribute array. I probably misspelled something. No, that's a silly mistake for me. And then I click on run, and we have this is the shape. It's a 5, because it has 5 columns, 1, 2, 3, 4, 5, and just one-dimensional array with 5 columns, 1, 2, 3, 4, 5. So this is a 5 and a 5. So there we have it. We have our array, 5 over 5. So the point is, the shape has to match. The shape has to match to do element-wise addition, subtraction, division, and multiplication. So if I want to say, now I can come here and say print, I can say here print a plus b, print, and I can print a plus b. And need to indent. In Python, indentation is very important, as you know. But if I click on a plus b, we're going to have this plus this. This is why the dimensions have to match, because we had along the dimensions, the dimensions. So it's element-wise addition. So the elements have to match, because that's what we are adding. So it makes a lot of sense. So this is 6 plus 1, or 1 plus 6 is 7. 2 plus 9 is 9. 2 plus 7 is 9. 3 plus 8 is 11. 4 plus 9 is 13. And 5 plus 10 is 15. So that's how you can be able to do addition. We can also do subtraction, but for subtraction, I want to subtract b from a, just so I can avoid negative numbers. So I'm gonna do it this way. I don't know, this collab keeps on, I'm gonna do b minus a, so I can avoid negative numbers, and I click on run. But this way I can bring this, yeah, that's fine. I click on run, and we have 5, 5, 5, 5. Look at that. So it's 6 minus 1 is 5, 7 minus 2 is 5, 8 minus 3 is 5, 9 minus 4 is 5, and 10 minus 5, 10 minus 5 is 5. How beautiful is that? And so that's how you do subtraction. Multiplication is the same thing. We can do b times a. We just use the multiplication, the asterisk, and you click on run, and you have 6 times 1 is 6, 7 times 2 is 14, 8 times 3 is 24, 9 times 4 is 36, and so on and so on. So that's how you can do multiplication, addition, subtraction. And division is the same thing. You use division operator like that. Like that. And the same thing, you get decimal point numbers for the division, but that's how you can do it. But the most important thing, shape. The shape has to match. 5 and a 5. The shape has to match. If the shape doesn't match, it won't work. Like for instance, if I come here and I say this is also 16, and I try to divide, then I'll get an error because the shapes are not the same. We have this B is a shape 6. We have 6 columns, and this other one is 5, so it won't work. The shape has to always match for you to do element-wise addition, subtraction, division, and multiplication. There's another way that you can be able to do if the shapes don't match. There's something we call broadcasting, and I covered that in my previous video on tensors, and you can look at broadcasting there. But it applies the same logic. It applies when working with a NumPy, with NumPy arrays. So that's how we can do it. And then we also did about, we talked about in my tensors, in my NumPy tensors, we also talked about matrix multiplication, which is very important. And with matrix multiplication, I did show you how you can go about it, but there's something that I want to show you, which I think is very neat, and I want you to see it in action because it's very interesting, and it's also something that I think it's just something to be aware of. So suppose we want to do matrix multiplication, and suppose we have I'm going to go on a limb here. Suppose we have an array here, np dot array, and we have this array as two-dimensional array, and we have 2, 3, 4. Then we have another one here for 5, 6, 7. And then, so that's one. Then we have another array here called array B, and this one is np dot array, and it is, let's say we have array, and it is one-dimensional array. Maybe we can say one-dimensional array. 1, 2, 3, 4, 5, 6. Let's make it a three-dimensional array. Actually, let's make it better. Let's make it a three-dimensional array. So 1, 2, 3, and we can have 1, 2, 3, and we can have another one here. We can have another one here. We can first close this, and then we have another one here. We can have 4, 5. We can have 5, 6, 7, And we can also have another one here. We can also have 8, 9, 10. And suppose you want to do matrix multiplication with this. Number one thing is to actually try to figure out what's the shape. What's the shape of this array, and can it be multiplied? Can it be multiplied? Let's see here. We can have np dot shape. We can have print, actually print, and we can print a dot shape. And we can also print b dot shape. Print b dot shape, and if I click on run, we can see the shape. And maybe I should have kept this as two-dimensional. I want to keep it as two-dimensional, but so at least it can be better. So like this one, suppose you want to do matrix multiplication. You can see the shape of this is 2, 3, and the shape of the other one is 3, 3. The shape of the first one is 2, 3. We have 2 rows and 3 columns on the first A. We have 2 rows, 1, 2, and 3 columns like that. 1, 2, 3. And on the second one, it's a 3, 3. We have 1, 2, 3. Maybe I can add another one here, and it can be 4, 3. I can add another one here. I can say 0, 3, 4. So like that. So it can be like that, and suppose it's not 4, 3. So this one, the question is, can this be multiplied? Now, this one cannot be multiplied because for us to be able to multiply, to matrix multiply an array or even tensors, when we come to tensors, the inner numbers have to match. Like this one, this is a 2, 3, and this is a 4, 3. So the inner numbers of both arrays that we are trying to multiply have to match. This is a 3, so this also has to be a 3 for us to be able to be in a position to matrix multiply them. So in that case, I'll go ahead and take off what I added before. I'll just take it off. And if I click run now, we have 2, 3, and 3, 3. The inner numbers, 3, 3, they match, and that can be matrix multiplied. So to matrix multiply, what we do is we use, we can just come here and we can say print. I just want to print, and I can say print, and I will print a dot mult. So I can maybe print, let me see here, I can maybe print A at B, and maybe we can see if that will do the multiplication. We'll do A, and instead of the addition, maybe I can use the at, and maybe we see what we get, and there it is. We get the matrix multiplication. A at B, it's matrix multiplication. And the thing I wanted to show you, you can see this is the shape here, and for it to be able to be matrix multiplied, I told you that the inner numbers have to match, like this 2, 3, and the shapes of the inner numbers have to match. 2, 3, and 3, 3. The inner 3s are matching. We have 3 from 2, 3. Then we also have 3, 3. we have 3 from 3, 3. So those are matching. So those inner numbers, they tell us whether we can be able to matrix multiply them. But the other numbers that are remaining, the other 2 and 3, that one will give us the shape of the resulting array, or even a tensor for that matter, once we finish with matrix multiplication. This one tells us that our shape is going to be 2, 3. And you can see it's a 2 rows, and 3 columns, 2, 3. So if, for instance, I had another one here and the shape changes, I cannot matrix multiply this. Like I say, maybe 1, maybe 3, maybe 4. And if the shape now changes, because now the shape is going to change from 3, 3 to 0, to 1, to row 1, row 2, row 3, row 4. So it's going to change to 4 rows, which is 4 and 3 columns. So 4, 3. I can just change the columns to 2, so we don't have to deal with a lot of 3s, because I think when we have a lot of 3s and we talk about the 3s, it may be very hard to know which 3 we are talking about, and that always creates room for confusion. But if I click on now this, we have the shape. The shape of A, obviously A remains at 2 rows, row 1, row 2, 2 rows and 3 columns. And the shape of B is, we have how many rows? We have 1, 2, 3, 4 rows. 4 rows and how many columns? And 2 columns. So if I click on this, I won't be able to run. It won't be able to matrix multiply because of shape mismatch. The sizes are different. And that's why we cannot matrix multiply. So for us to be able to matrix multiply, we have to make sure that the sizes of the inner matrix, they are the same. So let me see here. Let me see the size here and see how I can resize this to be a little bit better. So for us to be able to matrix multiply this, see the inner one is a 3. So this other one also has to be a 3, and these are the rows. So this one for the rows has to be a 3 for the second array B. So it has to have 3 rows for us to be able to matrix multiply it. Right now it has 4 rows. So we have to take 1 row here, and now we have 3 rows. And we have 2, 2. I don't like the 2, 2. What I can do is that as long as we have the rows matching, the inner numbers matching with 3, 3. I want to maybe make this a little bit bigger so we can see a little bit of what we are actually working with. So I can just make the numbers to be a little bit more here. And we can also make this the same. We can make this the same. So I want to have just a different shape here so we can be able to work with it better. So this is the shape of this. Now we changed it to, it has 1, 2, 3. So it has 3 rows and 1, 2, 3, 4, 5 columns. 1, 2, 3, 4. I need another one for 5. And 1, 2, 3, 4. I need another one for 5 columns. I want it to be another one for 5 columns. So this one, I want it to be a 3 rows, 1, 2, 3, and 5 columns, 1, 2, 3, 4, 5. So this is a 3, 5. If I click on run and I look at the shape, we have 3, 5. But since these two match, we have a 3 and a 3 in the inner dimensions, and they match, we can matrix multiply this. Like for instance, we can come here and say print. We can matrix multiply this. We can print, and we can print, what are we going to print here? We can print A matrix multiply the at sign B. And this can now work. If we click on run, it's going to print. Before I click on run, we have the 3, 3, the shape matching, but the resultant matrix multiplication product, the resultant array is going to be of shape 2, 5, which means we are going to have 2 rows and 5 columns. So we click on run, and we have the matrix multiplications, and the resultant array has 2 rows and 1, 2, 3, 4, 5 columns. So that's another thing I wanted to mention to you as we're working with these NumPy arrays, because we'll see these things as well as we work with our PyTorch, and especially when you're working with tensors. Last thing, and this is probably going to be the last, I want to show you something about flattening an array, and because we'll be able to see this when we're also working with tensors. And I just want to mention about flattening so you can see how it works in NumPy. And flattening an array, essentially to flatten it is the process to convert a multidimensional array into a one-dimensional array. And the flattening of array is often used when you need to process or analyze data in a linear sequence, or when interacting with functions or systems that require one-dimensional output. And there's different methods to flatten an array. In NumPy, you can use the flatten method, which returns a new array that is a one-dimensional version of the original array. And the new array is a copy of the original data, meaning changes to the flattened array will not affect the original array. And I'm just going to do this very quick, and I'll finish here. Suppose we have a two-dimensional array. Like say we have our array A is np.array, and this we're going to make it a two-dimensional. And first one, we have 1, 2, 3, and then second one, I need the square brackets, we have 4, 5, 6, and this is a two-dimensional array. Obviously, two-dimensional array, the point of flattening is to make this a one-dimensional array. So to make this a one-dimensional array, to flatten it is as easy as print, we can just call it array B, or we can just write array B, that's fine. Array B equals to np, we can say it's actually equals to A, this first array dot flatten like that, flatten, and this is a function, so flatten function. And we can click on print B, we can print B, and print B, and if we print B, this is two-dimensional. We print B, the goal to flatten is to make it one-dimensional. We click on run, and we have a one-dimensional array from 1 through 6, and it's one-dimensional. So that's the goal of flatten. We will use this a lot when we're working with machine learning, and when we're working with tensors, and we'll see the flatten layer will be flattening. It's not going to be in NumPy, obviously it's going to be in tensors, but the concept is the same, is to take multidimensional array or tensor data structure and flatten it to one-dimensional data structure. And that is going to end my presentation for NumPy. I just wanted to touch a little bit of a basic, get a little bit of basics, kind of like get our hands dirty with NumPy, before we start working with tensors, because once we start working with tensors, sometimes we'll be able to convert NumPy arrays into tensors, and that's why I just wanted to give you a little bit of an introduction to NumPy. If you have any questions on NumPy, there's a lot of resources online, but that's how we can be able to work with basic NumPy operations and create basic NumPy arrays. If you want me to dig deeper on NumPy, you can always leave comments in the comments section. Thank you very much. Happy people, and have a beautiful day. Thanks. Bye.